Hello, we're working on 9.1, my friends. And so let's see what we got going here on 9.1. Chapter 9 is about solving quadratic equations. We've already learned a method for solving quadratic equations. We learned it in, I can't remember what chapter at this moment, but it was the chapter where we learned to do the F word. We learned to factor. And so we learned the factoring method. So there's actually three methods of solving a quadratic equation. There's factoring, there's the square root method. Going with the square root method is completing the square and then using the square root method. And then there's the quadratic formula. They're going to show us, they're going to remind us about the factoring method in this section. They're going to show us the square root method and also the completing the square method and 9.1, and then the quadratic formula is in 9.2. And so that's kind of what our story is going there. Remember how you solve a quadratic equation by factoring? You get 0 on one side. You want your lead term to be positive. That's called standard form. You factor it, and then you use the zero factor property. That's where you set the pieces equal to 0 and solve the resulting linear equations. And then you check. And you check to make sure that you haven't made a mistake. There shouldn't be any extraneous solutions, so you are just checking to see if you made a boo-boo. And so this one's asking me to solve, and I notice it's quadratic because it has x to the second. So I say to myself, I got to get this factored, and it's a trinomial. It doesn't have a greatest common factor, so I'm making the first work, x times x, making the last work, which is 15 times 1. Yeah, I'm getting a different pencil. I don't know whose pencil that is, but it is not so good for this situation, is it? So x times x and 15 times 1. When I add those, I get 16. So this factors as x plus 15. Oh. X plus 1 equals 0. So we did step 1, which was, we noticed that it was quadratic. We got 0 on one side. It was already done. The lead term was positive. It was already done. It was in standard form, so we factored it. Now we're going to use the 0 property. So x plus 15 equals 0, and x plus 1 equals 0. And so when I take away 15 from both sides, I get x equals negative 15. And when I take away 1 from both sides, I get x equals negative 1. So those are my two solutions. Either x is negative 15 or x is negative 1. And I want to check both of those solutions. I'm going to get a calculator here in my humble studio that I have set up in my bedroom. So when I check, you check in the original. So x squared plus 16x plus 15 equals 0. So I'm saying what squared plus 16 times the what plus 15 equals 0. And we have negative 15 is one of the ones we want to check. So I'm going to put in negative 15 in both of these spots. So this is x equals negative 15. That looking like a 75. I got some handwriting problems today. I did a lot of gardening. Maybe that's the problem? Do you guys think? So I'm going to check that. I plan on putting it in my calculator. So negative 15 squared plus 16 times negative 15 plus 15. And when dust clears, I get 0. And I was expecting that I would get 0, and if I didn't, then I would know that, hey, there was a mistake. So I want to also check x equals negative 1. So the what squared plus 16 times the what plus 15 equals 0, and we're putting in negative 1 for the what. And so, and I can just go and edit what I have here. And in fact, just take out the 5, right? Makes it negative 1 there, and also negative 1 here. and I get 0. So they both work. I didn't expect that one of them would work and the other would not work or anything like that. I expected they would both work. The reason that you check it is because to make sure you didn't make a mistake. Now we're going to look at the other method. So this is the factoring, and this was a review of the factoring method. And the square root method, and so we're going to look at the square root method first. So the square root method says that for any real number k, if you have x squared equals k, now this has to be a number, it can't be a variable. So something like x squared equals 37 would be something I could solve using this property. Or x squared equals 16, or x squared equals -2. All of those would be things that I could solve using this. Even x squared plus 3 equals 0 would be something that I could solve using this property, because I could rearrange that where these were all perfect, right? I could rearrange this by subtracting 3 and putting it to the other side. X squared equals -3, right, if I subtracted 3, and then now it's of that form. What is not of that form is something like this. So this is a not for this form, is x squared equals 2x. That's not, because k is a constant. Do you need something, sweetie? You're good? So whenever you have x squared equals 37 or 16 or -2, or you rearrange it and it's -3, the property says that that x equals negative square root of 37, 16, -2, or 3, whichever one you have, right, -3, or x equals the square root of that value. So we'll give a try to that. This is for when we have to complete the square, so we'll come back on it if it's looking very much the same to you. Great. Wonderful. So we're going to come back on that. So we're just going to give a try to the strategy here. You isolate x to the second, and you pause and look at what you have. If on the other side you have a positive number, then when you use this principle that we were learning about right here, this principle, the square root principle, the principle of square root, right? You'll get two real solutions. If you have a negative number, like I had some examples with positive number 37, and I had an example with a negative number, -2, you'll get two complex solutions. Remember, those have I in them. If you have an x squared equals a variable, then this is not a good method unless you want to complete the square, and we're going to look at how to complete the square, but maybe you want to use a different method. So this one right here is an example of that. This is not a good method for just taking the square root of both sides, because it's got a variable on this side and not a constant. Okay, so we're going to give a try, and then if necessary, you simplify, you rationalize the denominator. You may have to solve for the variable. I'm going to show you some where you have to solve for the variable, not at first, but a little bit later. We'll look at one like that. And don't give rounded or decimal answers unless that's what's requested. Give the exact answer, and then you can check. Okay, so this is c squared minus 8 equals 0. They're asking us to solve for c. So we notice, you know what? If I added 8 to the other side, I would have c squared on one side and a number on the other. So I'm going to do that. And since 8 is a positive number, when I pause and look at what I have, I know I'm going to get some real solutions. So I'm going to use that principle, and that principle says that c would equal to the negative square root of 8, or c equals the positive square root of 8. Right? That's what that principle says. Two things it equals. And then it says, step 3, simplify. If necessary, rationalize the denominator. And so I have to simplify because 8 is 2 times 2 times 2. Right? For every 2 that are the same, 1 comes out. So c is going to equal -2 square roots of 2. And from the same reason, right? C is also going to equal positive 2 square roots of 2. When you look in the back of the book, or you may want to write that C equals plus or minus 2 square roots of 2. That's a great way of writing that, these two answers here. And I'm okay with you writing it that way. So a lot of people don't like to split it up right here. They keep it together. And so instead of splitting it up the way I've done, just to show the property and do it exactly the way the property was, a lot of times what people like to say is that this is going to be that C equals, ooh, I forgot my equal sign, equals plus or minus the square root of 8. And that's a great way of going. And then reducing the square root of 8, C equals plus or minus 2 square roots of 2. And then I told you that we were going to check our answer, and then of course did not give us enough room to check our answer because that's just how I roll sometimes, right? And so I am going to check our answer right here on my different piece of paper. And so that's my plan. And so right here I'm going to check to make sure that it worked. So when we have C squared minus 8 equals 0. So this is what squared minus 8 equals 0. And we have two values for C. We have C that is either positive 2 square roots of 2. So I'm going to use the positive one here, 2 square roots of 2. So this is when C is positive 2 square roots of 2. And then I'm going to take away 8, and that ought to give 0. And I'm going to put that in my calculator to check it. And so let's see here. I want parentheses and 2. And I think that we learned that it was okay to put the square root just like that, but it didn't like it when it was a root like the 25th root or the 4th root. You had to put the times in there. So I'm going to put that like there. And how you know what your calculator likes and doesn't like is by practicing with it a little bit. Minus 8 here, and that ought to equal 0. And so if it doesn't, then there's a problem, and it does. So 0 equals 0, great. Now the other one I wanted to check is C equals minus 2 square roots of 2. So I have what squared minus 8 equals 0. And so I'm going to stick in here negative 2 square roots of 2. So right there, a negative in there, and I get 0 as well. And if I didn't get 0, I'd be like, what? Because I should have. And so both of those work, and we did a lovely job of it. This is the exact value of the answer, positive 2 square roots of 2 or negative 2 square roots of 2. If they had asked me to write it as a decimal, which they hadn't here, but if they had asked me to write it as a decimal, I want to show you how you could get it as a decimal if they asked for it. So one of the answers was 2 square root of 2, right? And all I have to do is hit the S to D button, and that'll turn it into a decimal. So as a decimal, this is plus or minus, and then how many places did they ask you to round it to? Did they say to the 10th? Because if they said to the 10th, it would be 2 point and then 8, 2, which this is, we don't want, that's in the 100 spot, right? So this would be plus or minus 2.8 because we would round. Did they say to the nearest whole? If they said to the nearest whole, then plus or minus 2.8, I know it goes on, right? From there, to the nearest whole would be plus or minus 3 because the whole number is 2, 8 is big, so plus or minus 3. Did they say to the 100th? H-U-N-D, how do you spell 100th? I don't know. I think, I don't know. Right now, you know how my spelling is, the way my spelling is that sometimes I can remember how to spell things and other times I cannot, particularly when I get nervous. And so to the 100th is the 2. And so we would look over at the 8, and because it's big, we would bump that up to a 3. So this would be plus or minus is what it would become, 2.83, etc. So if they had asked me to write it as a decimal, they did not. They wanted the exact value, but if they had asked me to write it as a decimal, that's how I would do it using my calculator. Okay, so we're going to try the next problem here. 7x squared minus 5 equals 0. We notice that if we added the 5 to the other side, if you're thinking, could I have solved this using the factoring method because it's quadratic? The answer is no, because I can't factor that. It's a binomial, but it's not a greatest common factor or a difference of squares or a cube. And the same with this. I couldn't use factoring to solve that. And so, I'm going to try the square root property. And the square root property says get x squared by itself, and so that you have x squared on one side and a number on the other. And I can see that when I isolate x squared, that I can get it so that I have x squared on one side and a number on the other, right? And so now what I'd like to do is I'd like to do the square root property. So x equals plus or minus the square root of that fraction, 5/7. And I'm almost out of room, but that's not simplified, right? And so I'm going to come over here and simplify it. So x equals plus or minus the square root of 5 over the square root of 7. And no square roots of fractions, right? No square roots in the denominator. So I'm going to multiply top and bottom by the square root of 7, because that's going to get the square root out of the denominator. So I'm going to get x equals plus or minus the square root of 35 over 7 times 7 is 49, the square root of 49, which is 7. And so a little bit of simplifying that we learned in chapter 8 there. Okay, so, and then you could check your answer. You could plug it right in here, right? And make sure that it works. And so I think I will do that. I know that I don't have room, so I'm going to have to get here. 7x squared minus 5 equals 0. 7 parentheses here squared minus 5 equals 0. And my answer was either positive square root of 35 over 7. So I'm going to put in here positive 35 over 7. And you could kind of simplify it yourself if you like, or you can put it in your calculator. Either way, it doesn't matter. It doesn't matter to me. And so I'm going to put it in my calculator. So I have here 7. I have parentheses. I have a fraction. I have the square root of 35. And downstairs, I have 7. And all together, I have that raised to the second. So raised to the second. And then I want to take away 5 from that. And that ought to give me 0. And it does. So that's great. And then I want to check it with a negative. So if I put in a negative right here, you can see that how a negative square doesn't change that, right? So if I put in a negative right there, I ought to get 0 as well. And you can see that I indeed do. And so it works either way. And so we did a lovely job on that. Okay, so the next one, you notice that we don't have just simply x squared or c squared or y squared. We have x minus 1 squared. And that's what they were saying here. And I told you I would come back on that. They said for any real number k, so you have a real number k on the other side, in any algebraic expression x. So x is now representing an algebraic expression. So x could be, for example, x could be, capital X there, any algebraic expression, x minus 1, for example, or it could be 3x minus 2, or it could be y plus 4. Any algebraic expression there, and then you can use this property here. Whatever you have, because it's squared, you're going to unsquare it, right? Do the square root, and then solve for the variable. So we're going to try that on here. So I have x minus 1 squared, and I have equals the square root of 49. So this is a negative when I'm pausing to look at what I have. I know I'm going to get a complex answer when I take the square root, right? So this is going to be that x minus 1 equals plus or minus the square root of negative 49. So I'm using that even root property, if you will, right? And so that property said x squared equals k becomes, right, x equals plus or minus the square root of k, right? That's what that property is really saying. Now, the square root of negative 49, we learned in chapter 8.6, the square root of a negative is I, and the square root of 49, 7. So this is x minus 1 equals plus or minus the, the square root of 49 is 7, and the square root of the negative is I. So that's a complex number, 7i there. And then I just want to add 1 to both sides. Now, I can't add 1 physically to this because they're not like terms. And so typically the 1 would go in the front. So when I add 1 here, which is just going to leave x equals 1 plus or minus 7i. So there's two answers there. There's x equals 1 plus 7i, and that's a complex number. And the other answer, or x equals 1 minus 7i. And I can check both of those and just see how they work. So I have room, so I'm going to check that here. And so let's see here. We have x minus 1 quantity squared equals negative 49. X is 1 plus 7i, so we'll check the positive one. 1 plus 7i minus 1 squared equals negative 49. The 1's go away, and I get 7i squared. So that's 7 squared and I squared. And I know that 7 squared is 49, and I squared is negative 1. And so this is negative 49 equals negative 49. And you can go and check 1 minus 7i and see that it also works when you plug it in there. How is it going to be different? Well, instead of having plus 7i, you're going to have negative 7i. And then when you square negative 7, you get 49 when you square I squared. So you can see how it's going to work. Okay, so we did a lovely job on those. And so that's kind of the story on those three. Then they talk about how to complete the square. And we're going to need to be able to complete the square a little bit later when we graph some things. And I saw that it was coming this week. We no longer graph conic sections in our intermediate algebra, and we would need it to graph conic sections, and you'll be graphing those in your pre-calculus class. So we're going to practice completing the square. So what you want to do is you want to separate the variable terms from the number and arrange in descending order. So you want to get the number on the other side of the equation and then get these in descending order. And so you can make sure that it doesn't factor first, but they're asking us to solve by completing the square. And so I'm going to write this as y squared minus 8y equals, and I'm going to take away 1 from both sides, equals negative 1. So the idea for completing the square isn't to get 0 on one side. It's to get, first step is to get your y squared minus your 8y. And then if you have a coefficient of y squared, it says x squared, but this equation has y in it, you want to divide by that right now. Now I don't have a coefficient other than 1, so I don't have to do that step on this one. And then you want to complete the square by adding to both sides the new c. And how you find out what the new c is it's equal to b divided by 2 squared. Now b, remember on a quadratic equation, ax squared plus bx plus c equals 0. B is the coefficient of x, in this case the coefficient of y. So our b term is negative 8. So when we put this in here in our formula, this is negative 8 over 2 squared, which is negative 4 squared, which is equal to 16. So the new c is 16. So what you want to do is you want to add both sides plus 16. So I want to keep it in descending order, so right here would be plus 16, and on this side just plus 16, put it where you got it. And then the joy is that if you factor this, now you've created something that will factor. It's a trinomial. It's got y times y and 4 times 4, and in fact minus 4 and minus 4. So that this is y minus 4 times y minus 4. And you can write that as y minus 4 quantity squared. So that's what complete the square means, is to make this side into a perfect square. Now on the other side, I just have 15. And then why you complete the square is that your next project, your next story, is that you can use that square root property, right? It said x squared equals a number becomes x equals plus or minus the square root of that number, right? K. I'm trying to write that K, right? That's what that property says, right? And so now I've got this variable term. So I'm going to use this property. I have it squared equals a number. So this is the property. So I'm going to have y minus 4 equals plus or minus the square root of 15. And reduce it if it reduces, right? And 15 doesn't reduce. The square root of 15 doesn't reduce because 15 is 3 times 5. So now all I have to do is solve for y. And so all I have to do is add 4 to both sides. And those are not like terms. So I'm going to get y equals 4 plus or minus the square root of 15. And that would be our answer. And you could certainly check your answer. And I'm going to have to check my answer on a piece of paper. I'm actually grabbing paper out of the trash can to check, since I haven't given enough room to check there. And that's the good news about having a trash can full of paper, right, is that you can use it to check. So we're saying that there's two answers, y equals 4 plus the square root of 15 and y equals 4 minus the square root of 15. And so if I check back on my original, y squared minus 8y plus 1 equals 0. And so I'm going to have what squared minus 8 times the what plus 1 equals 0. And yeah, I made the parenthesis a little bit big because I could see that y was a binomial to have room. So y plus the square root of 15 and, 4 plus the square root of 15 right here. And if you wanted, you could FOIL this all out yourself and distribute. In fact, they practiced us doing that in Chapter 8. But you can put it in your calculator as well. So I'm going to attempt to put it in my calculator. So parentheses 4 plus the square root of 15. I need to go out, squared. And then minus 8 times here 4 plus the square root of 15 plus 1. And I get 0. And I expected that I would get 0, right? And if I didn't get 0, I'd know, hey, there's a mistake. And then I'm going to change this to a minus in here. And I'm going to show you that I get 0 when I put a minus in here as well, this minus square root of 15. And so that's just a little bit of editing on my calculator, right? So I'm going to go in here and back up here, and I'm going to change that minus right there to that plus to a minus. Oh, I used the wrong thing. I need to use the subtraction key. And I'm going to back up here. And I get 0. Okay. So so it certainly, both of them should work. And it did. Okay. So we did a lovely job on that. And we have one more to do. And they ask us to use completing the square. We have 2 more to do. And so I'm going to go eat my dinner and come back and do this other one.